Hello everyone, good evening. Myself Vidhi Kumari from Tech Octanet Services Private Limited welcomes you again in day 4 of Python development session by Mr. Harsh Pranjal. Without any further delay, let us start our today's session now. All over to you, Harsh.
Good evening, everyone. So today's topic we are going to cover is class and objects. I will try to cover the basics of class and objects today. Okay. So let's see. Okay, so let's first let's first keep the theory part aside. We will first focus on the practical implementation. See, after doing some practical implementation of class and objects, then I think you guys will be able to clearly understand what is the main role of class and objects. Okay. Okay. Guys, just one thing. Uh, just let me know if I want to access some values of this list one. Okay. I want to access the value this false zero. Then what will be the indexing I should use? If I want to access this false zero, then what type of indexing should I use? The values for these boxes. 4, 2, not 4 and 2. Okay, so see, first of all, let's find the index of this whole nested list. Okay, see, index of 90 is 0, index of this tuple is 1, index of this nested list is 2, right? If we are providing this 2, then we will get this whole list. Okay, then now the index of this first dictionary is 0, the index of this second dictionary is 1. Okay, if we are providing 1, then we are printing this second dictionary, right? And in the second dictionary, I want to access the value of false. That's why I am using key. In dictionary, we uses key to access the values. Okay, this is how we are accessing this false value. Okay, suppose I use it here, we will get it. Okay, so just let me know the output of this while loop. See, here a new keyword is used, that is break. Break will destroy the loop then and there whenever encountered. So, so suppose the value of a is 5, right? And 5 is greater than 0. So this is a true statement. This is a true statement. The loop will start executing. The first line the loop encounters is break. So the loop will break out from here to this line. Okay. And let me know this value is not false, right? This value is true. 5 is greater than 0 is true. Okay. So that's why this else condition is also not executed. So this loop will not print anything, right? Here one new keyword is used, that is continue. Continue will skip code lines, code execution. Suppose, see, what is happening here. The first we get this 5 is greater than 0. Okay. Then after that we decrement a by 1, that is this 5 is decreasing to 4, then 3, then 2, then 1. Okay. So 5, we come here, we decrease the value of a by 1, then this continue is encountered. Whenever the continue is encountered, it will skip each and every line of code which is written after that continue, right? So if I create an empty list here, this is also skipped. Okay. So each and every line will be skipped. The value of a will start decrementing, and the last value we will get of a is 0. So a is greater than 0. In this case, when the value of a is 0, 0 is greater than 0, we get the value false. Okay. And when false is encountered in while loop, the else statement will run, execute, and we will get the value of a, and the current value of a, the current value a is holding is 0, right? So this first value is printed by this loop, this list. This loop won't print anything, okay? And this 0 value is printed by this loop, as the last value of a will be 0. So these are two keywords we have seen right now, that is break and continue. Break is used to just break the flow of the loop whenever encountered. Whenever this loop encounter a break, it will just jump out of the loop, right? Just jump out of the loop. Continue will stop executing each and every line after it, after continue. So what happened, that everything before continue will execute, then whenever the continue is encountered, the interpreter will then again jump to directly to the loop. Okay, it will skip each and every line after that. Okay. Okay, let's see the practical example of some class and objects. Suppose, let's take an example, right? uh, Suppose we have an objective to create student management system. Okay, for student management system we have to create virtual students in this code, right? What do I mean by virtual student? That suppose there is a student in the university, so the student holds a, suppose a id, name, address. The student holds the marks of different subjects allotted to him, right? The department, the university name. So we have to create a virtual student for that, right? So syntax for class is class keyword, then my class name, and then right? So guys, and whenever you are trying to write the class name, always use this convention. First letter should be capital, and if there are any new words, start them with capital letters. So class, my, okay, just name it. Okay, column. Okay, just let me know one thing. See, suppose if we are creating a student, what are the requirements? First, the student should have an ID, name. Student should have university name, and what we will take. Let's take marks of 3 subjects. Okay. Now, see, each and every student have a common attribute, have a common requirement. Sorry, have a common requirement, that is university. University name of each and every student will be same, right? If you are creating a student management system for a university, then university name for each and every student will be same, and the ID, name, and marks of all the students should be unique, right? As the idea of a student doesn't match with the idea of another students. Okay, so for that, see, uh, for a common attribute, see, this is how we create a common attribute. Okay, we want university name, university here, and we don't know the name right now, so we're starting it with none. This is how we create a common attribute. Okay, and one more thing, inside a class, you can create, uh, you can create your own. You can create a different variables of different data types. You can also create methods, that is functions, and inside a class, you can create constructors. So constructors are something we will see. Just leave that one. We can create a variable and functions or methods. Variables are also known as attributes, and we have a common attribute here, university. University name of each and every student should be same. Okay, so let's create a function here. See, define. Uh, let's take the name of the function as construct attributes. See, this is the syntax for defining a function inside a class. Okay, def function name, and the first parameter should be self. Okay, the first parameter should be self. Each and every function inside the class should contain this parameter self. Okay, I will. So what is this self? Self indicates the different students. Okay, self help us to indicate different students. Suppose there are multiple students. Suppose there are student one and there are student two and there are student three. Okay, so self help us to declare that which student is working on this function. Okay, that is student one is working on this function, student two or student three, which student is working on this function is determined by this self variable, right? And it is not necessary to just name itself. You can name it anything, but naming itself is a convention. So what is the unique requirements we need for a student? That is ID, name, and marks of three subjects. So this is how we create the unique attributes. Okay, self.id, type, let's take it int, and then self string name, self, for marks I'm creating a list. And instead of let's create an empty string instead of list. Let's see. So we have created the virtual representation of a student, right? This is how we can virtually represent a student. Okay, these are different Unique attributes are always declared in the form of self dot attribute. Sorry, self dot attribute. Okay. So this is how we create a blueprint of student. Okay. If a student exists inside this code, then the student should have these many unique attributes and these many common attributes. Okay. So guys, just let me know any doubts till now. Okay. See, so we have created the blueprint of the student. Now we have to create the student for them. Suppose we create student one. So this is how we create a student. Okay. See what the type data type of this student is of type student. Okay. This is what I mean when we say that class and objects are used to create custom data types, right? The data type of this student one is of type student. See, if I type like this, I type, see, it is a class type, and the class type will be represented just by printing the student. Okay, and the student we have created here, it is known as object. Okay, so one thing about class is that class is the blueprint and object is the implementation. Okay. So class provides us the blueprint that each and every student should have these many characteristics. We have created a student one. Now we will create a student two. And by this method, we can create as many students we want. Okay. See, now suppose, see, this student have a ID, a name, a marks. See the use of self here. While accessing student1 dot id is equal to 123, if I will print student1 dot id and then I will print student2 dot id, both will produce. Okay, so both are producing right 1 to 3 because we didn't assign student to id. See guys, we have a student 3, student 1 and student 2. All should have all these attributes. Okay, id, name and marks. See, this is a function. Okay, and earlier we have seen how we call a function is that we use just the function name and if any attributes. Okay, if function returns something that we will catch into result like this. Okay, but in class and objects we call a function by its object name. Okay, first in class and objects function call should be like this. Function call we should use like first we should use object name, then dot, and then function name. Okay, any attributes if there are any, except self. No attribute required for self. Let's see. So here the first object we have is student one dot. We are calling the function and there is only self. Okay, the parameter is only self. So for self, this student one is going to be transferred to this self. Okay, so no need to declare anything here, any arguments. For student two dot construct attributes in dot ID. And we didn't provide anything to the ID. So okay guys, so start it now. See, this is the common attribute for each and every student, right? This is university one, which will be shared among the students. So this function we created here is also common for each and every student. Okay. Uh, okay. So for calling these, so let's do this one and student one, but ID one. Okay. See, let's create a model. Inside a class, inside a class, there are two types of attributes or variables. Okay, one that belongs to class, and others that belongs to objects. Okay, and the common classes, the common attributes or methods which belongs to class is shared by each object. See, can start. See, suppose this is a blueprint of a class. Okay, and we are creating. Suppose we are creating object one and object two, right? Inside of this class, there is a method which is common to this class. Okay, this method is for class. Okay, this method is common to class. Okay, so whenever we created a object, this method is shared with this object. This object can access this method. Okay, this object can also access the same method. Okay, suppose we have an attribute, common attribute. Suppose we have a common attribute. So this common attribute will be shared by this object and this object. Now, if both these common classes and common attributes will be shared by these two objects, then none of the object is the owner of this class and this attribute. Sorry, of this common method and this common attribute. Okay, the owner for this common method and common attribute is the class itself. Okay, this class is the owner of this common method and common attribute. Okay, so the thing that I'm saying repeatedly, that common, there is one technical term for that. The common attributes or method. The common attributes and methods are known as static methods or attributes. Okay, so I have examples. Okay, see this hello. We have see this color attribute. Okay, this color attribute is common to this car, so it is a static attribute. Okay, it is a class attribute. Each and every object will share this color attribute, and it is also known as the static attribute. Okay, the value provided here, color equal to blue. So we have some values. Yeah, so see, we have a car 1 and car 2. Okay, let's see how this, just observe how it is working. We will start this one again. So see, the color of both car 1 and car 2 is blue. Why? Because both of them are sharing this attribute only, right? Suppose I will change the color of this attribute with value black, then again, then again. Okay, wait, it is not executed. See, see, both are sharing the same attribute again, that is black. Okay, so if we will again change it with value white, then both are again sharing the same attribute with value white. So not the car 1 is the owner of that color attribute, not the car 2 is the owner of that color attribute. If we want to change the value of car 1 dot color to red, let me see if there are new, right. Printing this one. We have to print car 1 dot. See, the value of car 1 dot color is changed to red. Now we didn't change the value for car 2 dot color, right? Let's see what it will print. So the value of car 2 dot color is also printed white. Why? So whenever we are using, let me create one. Whenever we are using whenever you are we are using object dot attribute, what it will do, this object dot attribute is creating this object dot attribute, it will create a new attribute inside class. Okay, a new attribute will be created, and this attribute is only accessible only this object, because this object has created the attribute, right? It is not a class attribute, so no one can access this object other than this object. This attribute is not shared by any of the object other than this. Okay, so this is what is going on in here. This color attribute is created separately for this car1. This color and this color are not same. Okay, for that, let's print the ID for car dot color, car dot color, and print. So the owner of this common attribute is the class, right? So we use class name, that is car in this case. Okay, car dot color, and let's see what it will see. The ID for both car dot color and car1 dot color is different. Okay, what does it tell? That there is some memory one which is created to hold this car dot color, car1 dot color, and there is some memory too which is used to hold this car dot color. Okay, now we see we have created car, separate color attribute for car1. Okay, we didn't created the separate color attribute for car2 dot color. Okay, so id, see the id or the memory address of car2 dot color and car dot color, right? Hmm, it is on the right side. Okay, the id for car2 dot color and car dot color is same. So it is a common attribute. It is a common attribute which is shared by objects. Different objects are sharing this same attribute. Okay, and who is the owner of the attribute? That is the car or the class itself, right? So this memo, so this memory 2 will be accessed by this car2. Suppose we have created a car3. That car3 will again access the same color variable, because we didn't created any new one for car3. See, the attribute of all these three were same. The color attribute, the idea of color attribute for car is same, car2, car3. So it doesn't okay, so the number of objects doesn't matter. It doesn't matter that how many objects are there. Each and every object will share the same attribute, right? Okay, just let me know that you guys understood that what is a common attribute and how it is shared among the objects. Common attributes will be shared among the objects. Okay. Okay, the common attributes are just, okay. So this university is common attribute. Okay. So what we are creating here, we have created a student class. Okay. We have created a common. We have suppose we have created a common attribute. The name of that attribute is university. Okay, and we have multiple shared at unique attributes. Okay, we have multiple type of unique attributes. That is ID name. Okay, so see what happens when we create an object. Suppose we create student one and suppose we create student two. Okay, so this so the student one is accessing this university name. Okay, this student two is accessing this university name. But for this student one, a separate copy of ID name and marks were made, and for the student two also a separate copy of these values were made. Okay, a separate copy for this one, a separate copy for this one. Okay, the values inside this separate copy may differ from the values inside this separate copy. Okay, but both of them are sharing this university name, so the value of the university must be same, right? Okay, let's implement this one. Um, construct the second one. We will put student one dot ID equal to 24. It's one, two, student two dot ID equal to suppose 20 and print student one dot ID. What we are getting, see, the ID of student one is not same as the ID of student two, right? Both of them have their own ID variable, right? See, if we can print the ID of both of them, see, both of the ID of both of them. So the IDs are, so there are different IDs. It means that these attributes are stored in some memory location one, and these attributes are stored in some memory location two. Okay, but suppose instead of none, let me give it a value of my university. Okay, so print ID student one dot university student two. Right. See, both the IDs are same. It means that student one and student two are sharing the same university name. Okay. If you will print so both are sharing the same variable, so the values must be reflected as same, right? Okay. So instead of common attributes, we will now call this as static attributes. Okay. And instead of unique attributes, we will call it as object attributes. Okay. Each attribute is unique to its own object. Now, the use of this self. See, when I am accessing that university student one dot ID, okay, not this we have. When I am calling this function, see the function call for class and objects is object name dot the function and any attributes if any attributes if required. So for self, we don't pass any attributes. Okay, what self do? Self receive this object student one. Okay, and here it is written that student one dot ID is created. It means that a new copy of unique attributes were created where student one, this student one will receive a new attribute that is ID. a new attribute, that is id, right? So this is what this self is doing. This self helps to identify the object. The id belongs to which object. Okay, there may exist multiple objects, right? Student to student, say student 100. So this self helps to identify which id we are talking about, right? So okay, so this is the syntax. This is the syntax for object creation. Okay, syntax for object creation. Object name, new object name equal to class name. Sorry, class name, and with small brackets. And what we should provide inside these small brackets, we will talk about that when we discuss about the constructors. Okay, there is something implementation here. When we talk about constructors, we will see. Okay, so instead of a method, suppose let's define a method. Take mark. Okay, and again it is a class method, so I have to declare self. Instead of self, we can provide any name. Suppose object. Okay, pass is a keyword, right? See, if I remove pass, then the interpreter is expecting some code inside this function. Okay, indented properly. For that, it is showing error in this line, right? So if you don't want to put any code inside that function or any code inside that, suppose I have created a new class example, and I don't want to put any code right now, then we can just use this pass keyword, right? And this pass keyword will be used to just remove that error, or just to skip the implementation of that function. Suppose take marks. Let's create id, type in input, enter id of um, we have marks. Okay, for marks it is a list, so we have, let's create a for loop for I in range. We have values, so we need only how many we have cleared marks of three subjects, right? So the okay, so we have to create a list of total size 3. So what should be the last index of that list? If we have to create a list of total size 3, then the last index of that list should be 3.
Don't worry, guys. Our instructor is facing some connection at his end. He'll be live soon.
Oh, okay. So, okay, so the last part, I think, guys, did you get this one, this whole code? This is just a copy of this one we have just created earlier. Okay. So see, just note this one that we are just calling this method to construct the attributes. This is only for example. Okay. Okay. So I think I am unstable internet connection. Hmm. So just note that this is only for this construction type is only for example for construction of attributes. For construction of attributes we use constructors. Okay, but in this case we are not using constructor. It is a method. It is not a constructor, right? Okay. Just if I'm clearly audible, just anyone let me know what is the return type of this function. This function is returning. Does this function is returning anything or not? Does this method returns anything or not? Yeah. So the return type of this function is none because there are no return statement. There are no return statement. So it is returning nothing. Just declare it here. And also this function is also returning anything. So no. Okay. Okay. See, it is asking for a student. Okay, just take this one to the five. See, so this code, the construction is completed. We get our own memory locations for each object, the unique memory location. Okay. Now, student one is calling the take marks function The take marks function take marks for the student for student one. Okay, student one is calling some method to take marks for its own memory location. Okay, this marks is not going to affect this memory location. It is not going to affect this memory location, right? This memory location won't get affected. Okay, so see what happens after giving marks. Let's print student one dot id. We just print id. See, let me just tell you first that this id will print none. Okay, print none. See, first the construction is completed. These two are called. Then this method is called, and we are stuck here. Okay, enter id for student. Suppose I entered the id as 1234. Enter name of the student. Okay, okay. Enter marks one. See, we get a error here. Right, right. Just anyone let me know why this error. We have also a error name. Why this error? So see, we have created an empty list, right? And we are trying to access some index. So if we have created an empty list, that means that there are no index existing inside that list, right? So we cannot access a particular index inside that list. So what we have to do is just create a temp variable and put the type using append. There are multiple methods to just take inputs inside this string. Yeah, we didn't collect. First value, second value, third value, three. See, after providing ID, name, and mark, then again receiving the value of student.id as none, right? Right. So this is what it's doing. Suppose so we have a class, we have a shared attribute that is university. We have a shared method that one is construct, and we also have a shared method that is take marks. This one is take marks. Okay, we have created an object. We have created an object. Okay, student one, right? Okay. So student one. See, when student one dot take marks was called, so what student one object is doing, it is calling this function. Okay, okay, and it is a shared function, right? So what happened inside this function? Inside this function, we have created a ID, a name, and a marks list, right? Now, to reflect these changes, also we have a unique memory for the student to store its details, right? So we have created the ID, name, and marks inside this method. we didn't put it right now inside this memory location. We have to assign this, right? Nothing is assigned to this location. That's why it's printing none. We have to assign these values inside this one. Okay. For that, now for accessing these unique elements, or or object attributes. Okay. Accessing object attributes, we use syntax of object name dot attribute name. So here, where did we get this object name? We are calling this take marks function with the help of object student1, and then this student1 is transferred to this object. Instead of self, we are using the name object, but I will suggest all of you to use self. Object dot id is equal to id. Now what we are doing? We are giving this id. We are giving this id to the id variable inside here. See, this id is given to the id of the object. Okay. Again, we have object dot name is equal to name. Just let me know. I want to copy this marks list inside this marks. Can anyone just write the syntax for that? I want to copy this marks inside this marks. Means the I want to copy this list inside that our object marks. Okay. So this is how we can do it. Object dot marks. So marks is a list, so we don't just use marks, right? We have to use that copy function. That's it. See, now let's execute. We have 1, 2, 3, student name is first, let's do the mark. Now see, now after assigning these, after printing that student1.id, we are getting 1, 2, 3. Now if I'm printing student2.id, then see, for student2.id, it is printed none. Then again, the explanation is that student2 object has its unique memory location for its unique attributes. Okay, and it is accessing these attributes, and these values were copied inside these attributes, not inside this attribute. So this is again blank right now. That's why none. Okay. See, just copy this inside that. Yes, student one dot id. Let's perform some operations. See, object attributes, assigning user values to object attributes. Okay, so we can create any method as per our needs. Suppose we have created a method check pass or failed value object. Let's take itself. Suppose we are iterating for I in self dot marks. We are checking if I suppose any student get marks less than 50, then print failed. Okay. Otherwise, when everything ends, print pass. Okay. Here we are going to see one more use of return function, right? Sorry, return. See, let's execute this one. That's why I'm going to use there in VS Code, right? It always asks for the inputs in this search bar. Suppose into the ID of the student. Suppose I keep the ID as 23. Let's copy paste it. No, we will execute. We didn't call this function. Hmm. Suppose the marks for the first subject is 70, then you get 80, then you get 90. Okay. See, it is printing pass, right? If we again call this function, it will do this enter marks for the first student that is 70, and suppose 30, and then 90. See, it failed. It failed in one subject. That's why it failed for the semester or whatever. So, what does this return function do? When we are getting, see, I is accessing each and every value inside that marks. Okay. And what we have provided for the first example, we have provided 70, and then 80, and then 90, right? So for each value of marks, this if block is never executed, right? Not even a single value has the value less than 50. But for the second example, we have taken marks as 70, 20, and 90. So for 70, it's okay, but for 30, this if block is executed, right? It prints failed. Then again, it encounters the return. And what does the return statement do? The return just complete the execution of the function then and there, and it return back to the place from where the function is called. Okay, so that's why this next line is never printed. That's why after 30, this 90 will be never accessed. Okay, once the 30 is accessed, the field will be printed, and then again this return statement comes back to this line. Okay, so guys, just let me know that everything till now is clear. After this, we are going to jump to the theory part. Actually, for project student two. Oh, sorry, student one. Okay. So let's see some theory about it. So we have to why to use a class and object, right? So till now we have seen that attributes and methods which operates on attributes. Okay. See, whatever type of method we have created, these methods are what these methods are doing, that they are somehow processing the attributes. Okay, the attributes of the objects, right? Each and every method is processing attributes, right? So the attributes and the method which operates on attributes are listed inside a single name. See, 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 each and every one of these attributes or these methods are listed inside this class, right? Okay. See, whenever I draw this diagram, each and everything is inside this bigger box, right? So this is what known as encapsulation, right? So before this one, turn my down. There are four major pillars of OOPS. Okay. The first one is encapsulation. The second one is polymorphism, abstraction. Abstraction. The third one is polymorphism, and the fourth one we have that is inheritance. So the most difficult topic is inheritance to cover. Okay. See, these are the four major pillars of OOPS. So before OOPS, we are implementing methods, right? We have seen how function works. We have seen how there are different types of variables. So OOPS is a means that we can say that from OOPS we can use these four different types, okay, to provide some major functionalities to our program, right, to our projects. See, by this what I mean that suppose every single attribute and method which operates on that attributes are listed inside a single name, right? Listed inside this class only, this class student only. And this is what known as encapsulation, right? Okay, just let me know that suppose everything in this is not here. Okay, we have just created a code here, put it inside this one, execute this, and again. Now, suppose there is some programmer who have created this above code. Okay, this class and every these attributes and these methods. Okay, you are just you suppose you are the programmer number two, which comes to use this code in this project. Suppose so you are using it is so you are using this class to create different objects, right? So you don't know what this construct attributes are doing, what this take marks are doing, what this take pass or failed is doing. You are just using that function, right? See, when we have a list of value 1, 2, 3, 4, and we have created a new list, and we use that sorry, and we use that copy function. So we only know that what does this copy function do? This copy each and every element of this my list inside this my new list. But we don't know that how this copy function is working inside, right? We don't know that what is written inside that copy function. Okay. So that hiding. So let's take that one, and we have hiding not unnecessary, hiding implementation, and just providing useful information. It is known as abstraction. See, what does this copy do? We know that it copies each and every element of my list inside this my new list. Okay, so we know the information it is providing, that it copies, but we don't know that how it is implemented. We don't know that what type of code is written inside that copy function, right? So that is what known as abstraction. Okay, so there is one class, one module that is known as copy, and this copy function is present inside this copy module, right? By default it is present with list, but we can use it like this one also, copy dot copy, sorry, the copy minus. See, copy is the name of the module, that is copy is name of this class, right? And by using class name and then dot deep copy, we are calling some function of the class, and what we are passing, we are passing a argument, that is my list, and each and everything of this my list will be copied to this my new list. Okay, so when we use deep copy for nested lists, right? So this is what abstraction is, right? So today we are focusing only on these two, encapsulation and abstraction. So just okay. Hmm. So we have seen some methods, but without argumentation. Let's see. We have created student one, we have created student two. Okay, let's see how we can pass. Just, guys, and just let me know any doubts till now. What is encapsulation, abstraction? What is OOPS, class objects? How to create objects? See, just create a new file with name myclass.py. Okay, just create a class named student, right? Inside the student, create a static attribute. Always use comments. Okay, it will help you. Static, we have static attributes, that is university, and a university of type string. And suppose we don't know the name of the university, then again, see, let's see what is the constructor is. So see, see, the name I'm writing for the constructor and the name I was writing for any other function, that is suppose calculate marks, calculate marks. See, there is a difference between writing the name of these two functions, right? The constructor, this is the fixed name for the constructor, right? Init is the name of the constructor for a class. It is a fixed name. You cannot change. Suppose you cannot write that in and it will be act as a constructor. No, constructor is always named as init. And you have seen that before init I have used double underscore, right? And after init I have also used double underscore, right? So these double underscore methods are known as dunder methods, and these are special methods reserved in Python. Okay, so there are many dunder methods like I have something like the see call, delete, alter, attribute, sorry, directory, equations. There are many data methods. Okay, so no need to know everything, just init will do the work. So in the last, I think I told you that. Okay, so I have told you that we are only using this as an example, this construct attributes. Scaled up in large basic voice to create a separate file for constructor so that it is imported into the file that we will see. I think what you are mentioning that using a separate file for a constructor. So that is the basic way of creating a module, right? See, you have seen that we are imported that copy module, right? So inside Python, that copy module, see, this is how a module is always constructed. Copy, then first the name of the module. Inside this that module, there exists a init.py file. This is the constructor file for that module. And what you have mentioned that we have to said that we have to create a separate file for constructor. So this is the separate file for constructor always constructed for large projects. Okay. See, we have imported copy. Also, suppose you want to what? Suppose I have a name Django dot. Suppose this is some module. Okay, so inside that module also there exists a init file, right? So creating a separate file for init is only necessary when you are creating a module. When you are creating just a simple class, there is no need for that. Okay. Okay, so see, here we have seen that we are all calling construct attributes again and again to construct the that this unique memory location of each object, right? So that similar work is done by constructor, right? And this is the only way you have to use to create a memory location for those. So we will use self ID. We don't know the value. We will use self dot name. We don't know the values. We have self dot marks. So just always remember that constructor never returns any value. Okay, there is no return type in constructor. If you write any return type, you may get some error, right? So why did I say may? That the return type of the constructor is always expected as none, but you can if you so there is some topic that is this inheritance. So when you learn about inheritance, there are some things which are going on during runtime. So there may come a scenario where you have to return something from init, right? So for general scenarios, just remember that constructor never returns anything. Okay, you can call a function. So this calculate marks. You can call a function from inside a constructor. Okay, no worries about it. Okay, just see the when I'm calling this function, it is showing some error. So the owner of this function is the student class. So we can either call it by the owner name, or you can use this object. See, self is representing the object. You can use the object to call that method. Okay, so we have init. Now suppose define a function user inputs self again and again. Please don't forget about this self. So inside this self, suppose we have to take user inputs. Directly take input, no need for special variables. Input, then ID, self input, student, sorry, student name. Okay, so for marks, we will again go for that I in range field. We have a 10. So let's take this time float value. Okay, input, enter, marks, format this one, just create I plus 1, this value, and then set that marks dot append. See, just so we have created a function user inputs. Inside that function, please mention what this function is doing. Inputs from user, sending them to object attributes, right? Inside that init function, just see, I have to use this university. There are two types. You just use with the order name dot university is equal to input. See, we have to take the input for university also, right? So input enter university name. Okay. So if there is a problem with defining this input method, this input line here, we will say it shortly. If you return none in the constructor, don't we need to assign the return type user inputs? Yeah, we you can assign user types in inputs, no problem with that. But by default, every function returns none. It is not necessary to just mention return type with function, but it is a good practice, right? Writing this function descriptor or writing the return type, those are just good practice. Okay, so user inputs are there. Suppose let's leave the calculate marks right now. Creating object. Suppose we have created object student. Okay, so it is just a convention to only use the first letter of a class to create the object. But it depends on you how you are using. So in this code, when you are calling this construct attributes, you always have to use this object to call this construct attributes, right? But for this, when we have declared this constructor, whenever you are using this student small bracket to create a object, see, creating object, that constructor will be automatically called. That is implicit call to function. There is no need to call the function by yourself. It will be called by the interpreter to provide this memory location, to create this memory location for your object. We are creating a new object, right? S1. So the interpreter call that constructor for us to create this memory object. Okay. So each and everything, that is ID, name, and marks, will be created for this S1, right? See, just print S1 dot ID, and we didn't provide anything, it is none. So we will get a none. Oh, when did we call the, okay, see what is going on. See, when we are going to create an object S1 for a student, student is calling this init function. Then and there, we are prompted to enter the university name, right? So the university name will be my university, and see, then this init constructor will finish. Then again, s1 dot id will be printed. So by none, it means that s1 dot id is allocated, but the value inside that is none. See, now if we will university name, see, that is the problem what I was talking about, that putting the university name here inside the constructor is a problem, because see, I just have created an object in the last run, right? Then again I'm creating the object again. Then again this is asking me for the university name, right? So that is not right. Okay, you should only enter the university name once, right? So we will fix that one. See, the ID is there. It means that the memory location is allocated to this s1.id. Okay, if the debugger will work, oh, there is a argument, right? You just give a breaker here. Breaker. See, when we are creating this student, it call this init function. Okay, the next line. Okay, okay. So the next line, this input is called to get the values. Okay, so it is asking for the value of the university name, that is my university. Okay, then after that the execution returns to this place and the execution ends. Okay, see, the first jump that you have seen, that jump started from here, then again jump to this place, then after that we have the execution started from there. That is what that is something known as memory allocation for a class. It is an in-depth question, sorry, in-depth concept. We will see that one shortly. So see, we have a created student, we have created the ID. This is how we implicit call to sorry, not function, constructor. And for this problem, see, whenever we are creating a static attribute, we may know the value in advance, but if you don't know the value in advance, you will use the owner name, that is student, dot that attribute name, that is university, is equal to, and you can assign any value. Suppose 21. Okay, so this value will be overwritten by this value. Okay, 21. This is what we call the initial value of university, and then again we are accessing that same university variable and we are assigning uni1. Okay, so this is two types, assigning values to static variables, assigning values to static variables. Okay, now we have a student, and this is, so if suppose, so we have seen that there are multiple types of functions, right? With argument, without a return type, and something like that. There are total four types. So there are two types of constructor also. For constructor, for constructor, okay, just save this one first. Let's create a field. See, we have seen, so this constructor is known as default constructor. Okay, default constructor. Default constructor don't receive or don't have any parameter. Okay, so the only thing here we consider is parameter because we know that constructor never returns any value, so there is no return type. The only thing that differ is the number of parameters, right? So the default constructor don't have any parameters, and there is one parameterized constructor, and it receives IDs or it have parameters, right? So for parameterized constructor, let's take an example. Just doing def again the same name. The name is reserved. So suppose we are receiving from the user the predefined ID and suppose the predefined name. Okay, for marks we have to use user inputs and we have self dot id. So we have received the ID from the user, right? So we will assign that ID to this ID of the object self dot name. We will assign the name, but we don't know about the marks. So self dot marks and it will be empty, right? So this is how a parameterized constructor work. And for parameterized constructor, we have creating objects. Then we have implicit call to constructor, and this is how we create a parameterized constructor. See, so what it will show, right? It will print some dot ID. The ID for this one to know if the memory location is allocated or not. Okay. See, this is throwing an error, right? Type error. Student.init. That means that the constructor missing two required potential arguments means that there are two arguments were expected from us to give to the constructor, right? That is the ID and the name. Okay, the ID and the name. So we have to pass the ID and the name like this. This is how we we call a parameterized constructor, and we create an object using a parameterized constructor, right? So now it's no problem, and location memory location will be allocated to ID. If we will print s1.id, so s1.id is printed, that is 123. We have passed from it. Right? Suppose we will give it like 100,000. See, 1,000 will be there, right? Okay. So guys, just let me know that if there are any problem or any questions from your side. Custom creative class constructed. See, whenever whenever you are okay, just take a suppose you have a class and you are going to create an object, okay, and you have some object variables, right? These attributes are object variables, right? ID, name. Each and every student have their unique ID, their unique name. For that, you need some memory location to store those, right? So you have to create these memory location to store the values. Suppose whenever normally what we do, we just create, suppose we create an variable name a of value integer and we give value 10. Okay, what does this line do? That line will create a memory location. Okay, the name of that memory location will be a and the value stored there will be 10. Okay, and the name of the memory location will be a, right? So that is what this line is doing. So for storing this 10, you have to create a memory location, right? Similarly, for storing the data of an object, you have to create the memory location. And whenever you are creating an object, it is a good practice to create the memory location then and there, right? Suppose, so I have told you about a abstraction, right? Suppose you have created a class student, okay, and you have given that package to some non-programmer to use, right? So what he will do, he will just access like this s1.id and he will enter the id of the student 1234. So now what happened, that if you don't provide any memory location to that and you just have created s1 is equal to student, uh, so there you have created an object and there is no memory location is provided, then what will happen, if you want to store some value, you will get an error, right? You will get an error. Or what may happen, that if suppose this line also creates the memory location for id, right? This one line also creates the memory location for id. So what happens, that your object will create a memory location for id, a memory location for name, a memory location for something else that you are creating, or you can construct a chunk of memory with different memory locations to provide, to just hold this name or the ID or the marks of the student inside a bigger block, right? This is what init will do. See, just think it like this, that whenever you are creating a single variable that is a equal to 10, a will be created, memory location, and then 10 will be assigned. Whenever you are creating a class, that whatever code you have created put there, just remember some unique purpose. Whatever type of code you have put inside your class, that only operates over an object, right? To access each and everything inside a class, you have to create an object, right? So while creating an object, you have to assign the memory location to this object. See, if you want to use this a, you have to create the memory location to a, right? That is similar to when you want to use this object, you have to give the memory location to the object, right? See, here is the example. So in this case, whenever I am just doing this one, right? We didn't use any type of constructor inside this program. Whenever you are doing this, so the interpreter by default provide default constructor to construct the object. See, in this case, so in this case, we have provide our custom constructor, right? As per our need. But in this case, no constructor is there. So the interpreter provide us a constructor to just create this object. See, if this object is not created, if this object is not created, then how come you will just call a method by using that object? You have to provide some memory location to this object, right? See, if I will do this, suppose let's just print the ID of that object. Okay. And if we are taking any value, Mhm. That's coming. See, see, this line is printing some ID. It means that some memory location is provided to the student or dot one, sorry, student one object. But see, did we have provided any memory location to that student one? No, right? We may have created that ID, that name, that marks, but did we have created this self? Did we have created this student one? No, that student one is created by the interpreter. And if you don't provide any constructor, the interpreter by default provide you a constructor. Okay, by default constructor. If you want some custom code inside your constructor, like suppose you want to call that this function from inside of this constructor, so you have to define a, sorry, you have to define your custom constructor. So just a simple thing that, so constructor is used to create memory for the object, right? I think it is clear now. For putting value a equal to 10, you have to create a memory location a. Similarly, for calling any function or anything, you have to create a memory location s1. That is what this constructor is doing. Guys, I think everything is clear. So let's conclude this session. I will send you this Jupyter notebook, right? Okay.